Hello, everyone. I hope the first lesson went well for everybody. Here we are, lesson number 2. If you remember, we started the year off in ninth grade talking about properties, and we will come back to those properties of real numbers. We did rational and irrational. We practiced evaluating expressions in order of operations, which we'll do a little practice together in person. And then we started talking about polynomials. And we spent a lot of time at polynomials. And again, you guys are really good with this topic too. So a polynomial, if you remember, is an expression consisting of several terms. All right. On your line in your notes, go ahead and type in polynomials. There should be a text box already there for you. So some examples we have is x squared plus 2x. Remember, terms are each piece of this. So x squared is a term, 2x is a term. 3x to the third, x squared, 5x, and 9, those are all terms. Each piece is a term. 4x, negative 6y, negative 8 are all terms. So if you remember, a polynomial with just one term, something like this, again, you don't have to write this in your notes, just watch. That's called a monomial. Monomial. Okay, it has one term. On the line, I do want you to type in monomial. The sum, or if it has two monomials, two terms, is a binomial. Binomial. Remember that prefix bi means two. So a bicycle has two wheels, right? So binomial is just a polynomial with two terms. So something like 2x plus 1, two terms. The sum of three monomials, meaning it has three terms, is a trinomial. Remember, tri, Trinomial. Tri means three, like a triangle has three sides. A tricycle has three wheels. Okay, so trinomial has three terms. Go ahead and type trinomial on your line. And again, at any point, if you need to pause the video and rewind or just pause for a second to type, please feel free to do so. And anything that's four or more terms, we just say polynomial. And you probably will catch me even calling 1, 2, or 3 terms a polynomial. So go ahead and put polynomial on the last line there. And poly just means many. So you guys learned, I believe, last year in global studies, polytheistic means you believe in many gods. So poly just means many. All right, let's scroll down a little bit. The blank is the greatest exponent of any term in the polynomial. That was degree, right? So the degree is the biggest exponent, and we know that an exponent is the little number up there, that blue number. That's an exponent. So go ahead and type degree on the line there. So for example, the degree of x to the 9 plus 4x minus 5, well, the biggest exponent I see a 9. This, if there's nothing there, remember there's an exponent of 1. And 5 doesn't even have a letter with it, so there's no exponent. So 9, this is a ninth degree polynomial. Go ahead and on that line, type a 9. Remember, though, that you have to put your polynomial in standard form, meaning it has to go from the biggest exponent down to the smallest exponents. Okay, this is not in standard form. To put it in standard form, we would do x to the 7th first, then x to the 4th, then x to the minus x to the 3rd. Has to go from biggest exponent to smallest exponent. 7, 4, 3. Okay. Now the leading coefficient is the number in front of the term with the largest exponent. So think about, if you're the line leader, you're the person in the front. So on this line, I want you to type in leading coefficient. Okay. Again, it has to be in standard form. It has to go from the greatest exponent down to the smallest exponent. Sometimes the regions will trick you. They won't put it in standard form. They'll do something like this. And say, what is the leading coefficient? And everybody just picks 4 because you think, oh, that's the number in the front. But no, you have to first put it in standard form. So to put this guy in standard form, go 9x to the 9th plus 4x squared. Oh, I just realized they have 2x squared terms, so let's just make that an x minus 2x. Now it goes in standard form from biggest exponent down to smallest exponent. So my leading coefficient is 9. So for the example here, leading coefficient, let's check to make sure it's in standard form. Okay, x squared, x number, it is. So in that case, the leading coefficient is the number in the front, which is a 4. Go ahead and type in 4 on that line. And pause if you need to pause, rewind if you need to rewind. I'll take a breather here, and then we're going to go on to adding and subtracting. You guys are awesome at that. So remember we say that a polynomial is in simplest, you think I'd get better at scrolling, right? I did not. Simplest form, go ahead and type that on the line. When there are no like terms, when we can't combine anything else, it's down to its simplest form. It's done. And to combine like terms, remember that the variables and the exponents must match. And you'll see, and I'll remind you in a second here what that meant. But on this line, type in combine like terms. Combine like terms. So you can't combine a 2x and a 4x squared. They're two different things. Right? It's a cat and a dog. They're two different things. All right, I'm going to go on to the next page. Again, if you need to pause, go ahead and pause. So remember, when we add polynomials, all we do is combine like terms. There should be a text box in the adding polynomials box there, so go ahead and just type that in there. Combine like terms. You guys are really good. Remember, we did colors, some people did shapes. We did all different tricks here to help us combine like terms. Subtracting polynomials had one extra step. If you remember, the first thing you had to do was this keep, change thing. Again, I'll go over in a second what that means. And then you just combine like terms because it becomes an adding polynomial problem, which easy peasy, like terms. Okay. So again, go ahead and type those in your boxes. They should have text boxes already there for you. I say should. As you all know, Ms. Castle makes mistakes sometimes. All right, let's do some examples down here together. Add or subtract the following polynomials, and let's write our answers in standard form. Now, if you like the shapes, I'll do some with shapes. If you like colors, you can do colors as well. If you're at the point where you're like, I don't need anything this year, then, you know, if you don't need it, you don't need it. So find the sum, add, difference, subtract. Well, this is an add problem, so this is really easy. We just combine our like terms. So I'm going to put a circle around my x squared terms. Remember, these shapes really don't mean anything. You use any shape you want. A square around my x terms. I'm just going to put a squiggle under my numbers. And let's just combine like terms. 2x squared plus 3x squared is 5x squared. 2 plus 3 is 5. Okay, 3x plus 4x, 7x, 3 plus 4 is 7. 4 plus 5, 9. And that is it, my friends. That's how you add polynomials. Let's try another one together. Oh, I apologize. Before we go on, for these, I want you to drag the answers into the correct spot. So off to the side where you see 5x squared plus 7x plus 9, drag that in to the correct spot. All right, let's try number 2. I'm going to circle all my x squared terms. I'm going to put a box around my x terms. And I'm going to do a squiggle under my numbers. 10x squared plus 8x squared is 18x squared. 3x plus 4x should give me a 7x. 3 plus 4 is 7. And 4 plus 7 is 11. All right, go ahead and drag that answer into the correct spot there. 2 more examples, and then you guys are all set. Ooh, these become subtraction problems. So this has one extra step. We need to do keep, change, change. If you remember, keep, change, change is where we keep everything the same in the first set of parentheses. Change the middle guy from a subtraction to an adding. And then change all the signs after that. So this, I'm going to rewrite it. Well, can't do that because I can't see it. Is negative 8x squared, because a positive 8 becomes negative 8. A negative 3x would become a positive 3x. And a positive 7 becomes a negative 7. Now I'm just going to cross it off because I don't want to get confused. And now, go ahead, my friends. Same thing. 7x squared plus negative 8x squared gives me a negative 1x squared. 8x plus 3x gives me an 11x. And negative 9 plus negative 7 is a negative 16. Again, if you need to use your calculator for those, totally fine. All right, that's my answer. Drag and drop your answer into that correct spot. You didn't know the answer because it should be the only one left. But let's do this together. It's a subtraction, so we have to do keep, change, change. So you keep everything in the first, change the middle, and change every sign after that. So a minus becomes a plus becomes a minus becomes a plus. And now we just combine our like terms. 4x squared plus 2x squared gives me a 6x squared. A negative 6x plus a negative 8x gives me a negative 14x. And negative 10 plus 13 gives me a positive 3. That is my answer. Go ahead and drag and drop that one also into that spot. We will have a chance to practice some of this together when we are together again in person. If you have any questions, please bring them to class or email me. All right, nice job, guys. I'll be checking to see you did your homework.